Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. Good morning, good afternoon, and good evening. My name is Matthias Gröschel, and I welcome you today for today's AI and Health webinar series. As you may know, today's World Telecommunication Information Society Day, which marks ITU's 157th birthday. This year's theme, Digital Technologies for Older Persons and Healthy Aging, is directly relevant to today's session, which is entitled Harnessing the Power of Data to Save Lives. So I really welcome you to today's session in AI for Good. And the first thing I want to do is introduce my co-moderator, Eva Weikind, today. Eva is the Chief Medical Officer in the Artificial Intelligence Department at Fraunhofer Heinrich Hertz Institute in Berlin, Germany. And she plays a central role in ITU's standardization efforts of AI for Health. Her research focus is on clinical evaluation of ML AI data-driven algorithms. And she is in the perfect position to do so because prior to that, she's trained as a resident neurologist in the hospital for many years. Hey, Eva, how are you doing today?
Hi, Matthias. I'm great. Thank you. I'm excited for today's excellent speakers, and we have in total 5 panelists today. And I have the privilege of introducing Dr. Eng Lim Go. And Eng Lim, would you like to say hello and switch on your camera?
Hello, Eva. Thank you very much. Yes, my name is Eng Lim, and I'm Chief Technology Officer for Artificial Intelligence.
Yes, right. He works as a Senior Vice President and Chief Technology Officer for AI at HPE. And Eng Lim graduated with a degree in engineering from Birmingham University and holds a PhD in computer graphics from the University of Cambridge. And his research interests are manifold and best illustrated by some of his recent work. Eng Lim was awarded NASA's Exceptional Technology Achievement Medal for successfully demonstrating the first commercial supercomputing platform on the International Space Station. And he was also involved in the deployment of AI in Formula One and in co-inventing blockchain-based swarm learning applications, which was also featured on the Nature cover. And I'm very excited for Eng Lim's talk soon, but before I'll hand it over to you, Matthias, to introduce our next speaker.
Thanks, Eva. We have Claudio Caimi today. Claudio has 2 master degrees, one in computer science and one in marketing. And he is the IT Security Unit Senior Program Manager at Hewlett Packard Enterprise. Claudio's background is in Unix systems management and the technical marketing program management of a whole lot of different projects, which, if I mentioned them all here, would take the hour. But his recent work included European Union-funded projects in cybersecurity that were part of the FP7 or Horizon 2020 research programs. Welcome, Claudio, and back to Eva.
Thank you, Matthias. I would like to introduce Iveta Luchowska. Iveta, would you like to say hello and switch on your camera? She is Principal Data Scientist and AI Ambassador at HPE, and her expertise runs across a range of topics, including AI, data science, risk management, data security, and she is an advocate for AI and ethics as well. Iveta has provided guidance on more than 50 AI projects and is HPE Women's Excellence Award winner. Welcome, Iveta. And back to you, Matthias.
And I'm honored to welcome Nicola D'Ascenzo. Nicola, hello. Nicola is a physicist, and he graduated from the Universities of Pisa and Hamburg. He's a professor of biomedical engineering at Huasong University of Science and Technology in China, and he recently co-founded the Department of Medical Physics and Engineering at the Instituto Neurologico Mediterraneo, which is founding new institutes. You know, not everybody gets the honor to do so. And Nicola's core interest is the new digital sensor strategies for PET-CT, so positron emission tomography. And I'm looking forward to hearing more about this. Back to Eva.
Thank you, Matthias. I would like to introduce Edmondo De Salvo. Please say hello, Edmondo. He's a trained physicist, graduated from University of Messina and Trieste in Italy. And Edmondo is a strategic advisory consultant working for the HPE, a worldwide AI and data practice with specialization in business to IT alignment consulting. And Edmondo's focus is on development of advisory services on AI, big data, IoT, and mobility. And it's great that you all are on board here today. And thank you to our panel that you join us today. And now, with no further ado, I'd like to give the floor to Dr. Go. Eng Lim, please take us away. The floor is yours.
Thank you very much, Eva. I'm as CTO for AI, right? What I really mean is that the goal is getting value from data, with AI, machine learning, and analytics being the means to it. So AI is the means, while the goal is extracting value from data. In fact, on the title of our session today is harnessing data, right? Now, the connection between data, machine learning, and AI, I would put as follows, right? Data is the source of a machine learning to be artificially intelligent. This is how I make that connection, right? And you can hear the word data a lot today, and in fact also on today's title, right? And it's so much so that its increasing importance is making companies now consider that data should not be cost anymore, should not be treated as cost anymore, but instead as a new kind of asset, right? With value on the data chain, on the balance sheet, right? With value on the data balance sheet. So this is what we're talking about today, especially for in AI for good, right? We'll be talking about these use cases for humanity, in particular in healthcare, and specifically in detecting and preventing diseases. And if we have more time, I also would like to talk about something that I'm also very keen on recently related to that. And that is a kind of distributed learning where you can connect hospitals of the world by a network, and then the machines amongst them are learning from each other without sharing any private patient data. So let's hear from the panel, right? You'll hear practical and profound use cases related to humankind. Eva?
Thank you very much, Eng Lim. I'm excited to hear more about and learn more about that. I would now like to hand over to Iveta, who wants to also give a talk on her work. And after that, we will also hear Nicola and the others talking about their work. So back to you, Iveta.
Thank you so much, Eva. So from my perspective, as Dr. Paul mentioned, I will give you the concrete example of how we are actually moving the needle when it comes to using AI for healthcare and life science. And particularly super interesting project we have delivered with a partner of HPE on dengue fever. And the story is around actually building a prediction engine that would predict the next dengue outbreak, so that actually preventive measures are taken on site. And this is mainly deployed at areas with extreme poverty or developing regions, so emerging markets. And for these, we are using interesting data sets that vary from dengue cases, precipitation and temperature, demographics, but also economics and incomes of the region, so that we actually can map the people living there and can show if they can afford the specific healthcare and what kind of actions needs to be taken locally. So super interesting use cases that I will be showing later on.
Thank you very much, Iveta. And now I would like to hand over to Nicola and the others who want to give a presentation on their work and yeah, they also have prepared some slides for us. So I'll hand over to Nicola.
Yeah, thank you. And so I think Claudio, you can share the slides. And
yes, yeah. So let's go through our presentation.
Yeah.
So we have a few slides, and so today we will talk about the Gatekeeper project that is meant to empower the citizen and building a healthier society. And the speaker today will be myself, Edmondo De Salvo, and Nicola D'Ascenso, that are already being presented. But first, we have the agenda that is to give some hint about the European Union activity, and also also, sorry, let me go in presentation mode, and also give some hint about the Gatekeeper project. So, but considering we are today in the framework of the United Nations, let me first establish a relationship among the European Union and United Nations, which is promoting his with his 20 and 30 agenda for sustainable development, the 17 Sustainable Development Goals, and which is the world leaders are committed to end poverty, to protect the planet, and ensure the people enjoy peace and prosperity. On the other side, the European Union is fully aligned with the development activity of the European institution and the member states in the Sustainable Development Goals, as from the reflection paper named Toward a Sustainable Europe by 2030. The European Commission pursues all these objectives with many instruments. One of the most powerful is the funding of research and innovation. In fact, today we will talk about a funded project that is starting in 2019 and is going to end roughly end of the next year. That is from the last funding program, Horizon 2020, which is particularly targets 2 of the 70 goals listed here. We can see here in green, we have to ensure healthy lives and promote well-being for all the ages. And the second, that is number 9, that build resilient infrastructure. In fact, Gatekeeper mission is stemmed from the necessity to target constantly rising average of society, which entails a rapid decline in physical and mental capacity for aging population. And the major goal are to connecting people, that is healthcare provider, businesses, entrepreneur, elderly citizen, and to build a trust and secure platform to integrate large-scale deployment to integrated digital solution, mainly for AI and big data. That is for the purpose of the healthcare domain to obtain personalized disease detection, advanced health monitoring, and early intervention for elderly. As we can see here, we have 43 partners that are from large enterprises, small and medium research academic organizations, standardization body, legal support, and social economic analyzer. And we have 40,000 individuals providing the data that will be run by 7 pilots that we will mention after. Let's now talk about, with a few slides that will be covered by Edmondo, what is the activity of Hewlett Packard Enterprise inside this project. Edmondo.
Thank you, Claudio. Well, healthcare data platform, it's an enabler for the organization to centralize, control and share, and definitely take advantage of the patient data coming from multiple and heterogeneous sources and in different formats. Now we are going to enter into some details related to the specific data platform oriented to the implementation of artificial intelligence use case in healthcare space and enabling a human collaboration. At HPE, we please, one slide back. At HP, we defined a reference functional architecture for digital data platform for AI and analytics. This model is applicable for almost any type of analytics use case, not just artificial intelligence only, and it's applicable also for the needs of any industry. It's a standard stack diagram representing intra-domain horizontal layers from infrastructure layer to the higher layer serving the business use case, together with the three cross-cutting functional areas, I mean the governance, the orchestration, and the security and trust. Now let's pass to have a look at what it might be its structure, characterization, and personalization for the case of a healthcare data platform. First of all, let's consider that in healthcare context, we have a core data sets. Think, for example, to electronic healthcare record databases or clinical notes, but many use cases are also based on new data generated by devices and like sensors. The infrastructure level include all the hardware pieces at the basis of the platform. Servers should run GPUs to support heavy computing requested by machine learning training, and in hybrid architecture, some pieces can run even in the cloud, provided that security and privacy needs are met. That architecture for ingestion and distribution are responsible for collecting raw data, for example, data coming from healthcare sensors, and from them into a format usable by the data scientist. Tools like NIFI that you see in the picture are often used to create ingestion flows supporting a wide number of data types and protocols. Data stay in the data storage layer that can be distributed or centralized. An element characterizing healthcare data platform is the semantic data lake, which provides a semantic interoperability required to correlate patients' health data with the external measures. For Gatekeeper, the FHIR databases is used to standardize electronic data exchange and to implement medical ontologies. In the data processing and analytics layer, for example, execution engines enable search, transformation, and analysis of big volume of data stored in the layer underneath. For example, Spark can run machine learning jobs on top of data lake. And specific rule engines are also sometimes required to support decision by the end user and to help to implement sophisticated logical data validations. Next slide, please. Okay, now let's take a closer look at the Gatekeeper architecture. I would like to underline that in order to comply with the guidelines of the European Union and the strong demand of the public sector industry for solutions based on open source software, the basic structure of Gatekeeper was built using precisely this type of tools components, also combining them with the specific international standards of the healthcare sector. I refer, for example, to FHIR and HL7. This has allowed us so far to build a common platform on which various pilots are being developed. One of these we will see later, which in turn can leverage on both open source element and commercial products. Let me hand over back to Claudio for an overview of the pilot that we are under development on top of Gatekeeper platform. Up to you, Claudio.
Yes. Okay, so in this picture here, you see on the right 7 medical use cases that are, for example, diabetes, predictive modeling, is Parkinson disease treatment, decision support system, primary and secondary stroke prevention. These 7 use cases here are mapped on the picture on the left with a geographical map with 7 pilots that are running inside Gatekeeper. And we have Aragon and Basque Country for Spain, Milton Keynes for UK, and Saxony for Germany. We have Puglia pilot, Attica in central Greece. And among the 7 pilots, we have also added 10 open, so-called open caller. One of those is the Molise pilot that is driven by Meromed. That will be the speaker today presenting the use case. So the floor is to my friend Nicola to present his section on the pilot for Neuromed.
Mm-hmm. Yeah, thank you. Thank you, Claudio. So yeah, my task now is to show to you what we can do with such a nice platform. And that may be interesting also for scientists. I would start with one of the sentences from one of the panelists before, from Dr. Go. He told that we need to make value from data. And this is exactly what happens in all the research facilities which are making use of such an amazing platform. So today, I don't want to convince anybody that this platform is the wonderful one, but I would like to convince you that artificial intelligence based on our platforms is sort of driven away, sort of driven in the future. So medical images. So I'm going to focus on that. Medical images are a very important healthcare trend. So Claudio Caimi already mentioned it, that the transformation of health and care for a digital Europe is going to benefit people. So this is a strong EU sentence. And for EU, there are priorities about citizen secure access to data, personalized medicine through European infrastructures, citizen empowerment and digital tools. You may be surprised at that. Out of most of the storage capacity, medical data generated in 2020 are an enormous amount of exabytes. 70% of all that are medical images. So the first question here is, why data federation are the key for a proper use of this digital images data? Next. So the focus that I'm going to show is one of the key healthcare questions that we nowadays have. My grandgrandfather, in fact, had exactly this problem called Parkinson's disease. So Parkinson's disease has a very specific trend. So as you see in the picture on the left, it is about the degeneration of dopaminergic neurons. So when this happens in the brain, the symptoms are really dramatic and traumatic. So there are motor skill symptoms, vocal symptoms, as you see in the right picture, tremors, walking difficulties, mental behavioral issues, sense of smell, sweating and melanoma, gastrointestinal issues, and of course lots of pain. Next. Now, such a symptomatic framework is usually available only very late. So the diagnosis nowadays is done when all these symptoms are coming out. So however, at an already clinical stage. But what is very common in neurodegenerative diseases is that there are very early symptoms, which are not specific at all, like depressions, sleep disturbance, sense of smell, at a subclinical stage, which is very uncertain right now. So in this moment, it is not possible really for the clinician at such an early stage to understand very well what the problem is. And so the illness is getting sort of asymptomatic or very mildly symptomatic until it's much too late to make any possible correction to it. Our key point and our innovation was to find out exactly when at a very early subclinical stage, the possibility of a diagnosis. And this is when, with the partner NIM Competence Center, we developed radiolytics. Radiolytics DOPA is based on the Edsmera platform, and instead of speaking too much, I'm going to show you exactly how it's going to work. So, and I will drive you through what in practice it is done there. So, Claudio, the next. So, the first step is blood metabolomics. So, after a simple blood instruction, we are able to analyze 630 metabolites. Here is how you enter the platform and you upload the metabolomics data, which come out after that. This happens all in AWS. So this could be done. This is done with a very simple web interface, and it's data shipped to the Edsmera platform. In the Edsmera platform, we have all the artificial intelligence capabilities and all the algorithms which are then calculating after inference the risk of possible Parkinson disease. In this moment, this is only based to blood metabolomics. The result is sent back to the AWS, and the clinician or the user can get the result directly in his platform without any. In this specific case, we pick it up, yeah. So clearly, just to show there was a risk. If the clinician gets that, it can request PET imaging. So the patient, all in that case, may get a PET image, and the PET image is again uploaded into the platform. And after upload, again, new artificial intelligence. So the data are shipped back to the Edsmera platform, and in the upload, again, we developed specific imaging algorithm which recognize textures which are not visible at the nude eye in order to understand if the risk is there or not. In particular, at this stage, we analyze dopaminergic neurons. All that in the Edsmera platform again. The result is shipped back. And we are able then to visualize and to understand the risk. Now, this is not only sort of a clinical example. A good thing of what we develop in the Edsmera platform and also within radiolytics is for basic research. So our interest is in translational platforms. So what we can do with small animal models. In this sense, if we have small animal models of a certain disease, we can train our algorithms and understand the disease much better in small animals, and then translate it into the human case. In this case, here you see some examples of how we analyze PET images of animals which are developing Parkinson disease. Because of transgenic animals developing Parkinson disease. Here you see, the image of a mouse is coming out. For that, we have exactly the same algorithms tuned for humans in animals. Preclinical animals are a very important test bench for us because we can emulate quite well any possible textures and possible parameters, tune them for the human case. We have lots of different possibilities of extracting such parameters. Finally, the platform is excellent for models training. And also for the developing new models. This is what happens when you upload then models available for training inside the platform. So in that case, as a data scientist, then you can develop all the artificial intelligence and CNN directly inside a centralized platform. Why this is important? It is so important because all the other scientists have access exactly to the same code. And in the open source idea, which we all have, that's critically important in order to cross-validate the models. So as a scientist, it's for me extremely important to develop a model to let it use also in the other from other communities, people in the community, and to cross-validate what I do. So we are so in this way working all in open access and working all sharing the data among each other. And this is here an example of our daily life within the EDSMER platform. Only in this way, we are really sure that the models that we are going to develop could be then really translated into a reliable clinical application. So all that in a very simple and very effective communication together with HPE, NIM, Neuromed, and please, you can have a look to our platform, which is directly available on the web for tests and of course for feedbacks. Thank you.
Thank you, Nicola. That was fascinating. I'd like to kick off discussion with a question for you, but before, let me please also ask the audience, post your questions, the shorter and the more concise, the better, into the neural network, and we will take them to the panelists. You can ask whatever you want, whatever you find interesting. We won't filter them, so please go ahead. So Nicola, so as a physician, I was really intrigued by the work on Parkinson, and I wonder, and especially, I wonder how difficult, how challenging it will be to get metabolomics data for every patient. But this is the future, obviously, really personalized medicine. So I'd like to ask, what are the bottlenecks of these tools, Radiolix and Esmeralda, that you need to solve in order to really go full way the personalized approach?
Yeah, so I think that the innovation that we are going to insert into that is what we call data-driven clinics. So as a clinician, you know very well that PET imaging is very expensive. So, and of course, if we speak about Parkinson, not all Parkinson patients will do a F-DOPA scan, right? So we have neurologists also here in the panel today. I'm sure they don't. Yeah, so they will not because it's so expensive. So metabolomics, yeah, that's another important bottleneck. You know that each metabolomic kit will have a sort of different outcome. Even the data, the kind of data we get are so heterogeneous. So we have here these two main bottlenecks when we speak about artificial intelligence in digital healthcare. Heterogeneity of the data, data from different machines and from different producers will have a different fluctuation, will have different noise, will have even different absolute values sometimes. And second, most of the data are sometimes expensive, although so valuable. This is making the development of algorithms in personalized medicine so complicated. Now, in order to solve that bottleneck, our scientific questions was, first of all, how to deal with such fluctuation, and second of all, was how to optimize the use of the data. So if you, in the example which I've shown, the data flow is so that you start with metabolomic only, and only if there the risk is sort of high, then you order a PET scan. In this case, you will not do a PET scan for all patients, yeah? So, and this is already a simplification of the second bottleneck. But what about the first bottleneck, the heterogeneity? Yeah, so for the heterogeneity, the key important point that we have in the platform is to share data coming also from other institutes and from other co-workers, co-partners. So when we share all this data, we learn from the data how they fluctuate. That's the key technology that we developed there. So our artificial intelligence learn the fluctuations directly from the data. So they will know how to deal after a while with the fluctuation. And this is much beyond the simple pre-processing with, for instance, OPLS, or, of course you do some pre-processing, but then the key point is to learn the noise from the data. Okay, so that's the key bottleneck. And then maybe if you ask how personalized can be personalized, this is really then about the data volume that we have at disposal. So, and there the cross-disciplinary cooperation between physicists, mathematicians, and clinicians is so important. This is why we also collect keywords from clinicians like you, so that enable us to label the data in a more and more precise way. So this is a very important cross-disciplinary question there, and I think that cross-disciplinary is making a I think is the goal of our generation, right? So we are really more and more cross-disciplinary, and this is the strength of AI.
Yeah, that's a great response. And what just became clear to me as you responded is maybe that's the best way to convince hospital managers to invest in data structure, to convince them, if we have data to train models, we can make healthcare delivery more efficient, and you will save money.
Yes. Yes, and also my point is that of course when we're speaking about patients' data, we need to be very careful about data privacy. It's true. All this is true, but nowadays we developed so many ways of anonymizing those data that I think that any patient could be very easily. It's very easily explained to patients. Yeah. You cannot imagine how many. So my parents are medical. I tell you this story. Yeah, my parents are medical doctors, and some of their patients are going to my parents asking if they can come to the clinical trials which I develop, just to give their data. So I think this feeling among common citizens is now getting stronger and stronger. Yeah. So a long time ago it was to convince people they should donate blood. And now it's very normal. Yeah? Every of us is maybe donating blood. Now is maybe the time to convince people, to explain people that donating some data may help to prevent very terrible illnesses. So, and this is the key. This is the key. So, of course, more data we have, more value we can get from the data, and more precise algorithm we can tune. So. This fluctuation that we learn from the data is the key to make it more and more personalized.
And I just remember during one of our last webinars, we had the audience asking the question, so I have my CT scan on a CD, like, I don't know who can still read them, but he's like, where can I donate this? And it's just,
sure, what to do.
Data, but
yeah. So, for instance, within Gatekeeper, as we are a data federation, that is possible to contact one of the nodes. Or in this moment, within European Union, there are many more data federation coming out. It's coming a new data federation for cancer research. So, and also there, it's completely okay to let the data being anonymized within one of the data federation, and to put in the node which is really dedicated and focusing exactly on that topic. For instance, I mean, if you think about, we all know about COVID, right? So unhopeful. So CT became a standard method now to find out COVID, and all this is artificial intelligence based. How they did it? They took a CT scan from all the patients and trained the algorithms. Yeah, there is plenty of literature now. So that was sort of easy. Of course, for neurodegenerative diseases is a little bit more complicated, yeah, because also the variation is a little bit larger. And this is why we need data to learn. So on our side, we have all the tools and wonderful tools, yeah, so where we can analyze all that and get out the most interesting part. Very recently, for instance, in one of my last publications, we got an interesting age-dependent trend for Alzheimer's disease. So where you find out that the early onset Alzheimer's disease is really something different. So all this can trigger new methods or new drugs, new therapies. That's extremely important.
Early intervention.
Yeah.
Early intervention, early intervention, early intervention.
Let me now hand, Nicola, you and I were talking too much. Let me hand over to Eva to involve the rest of the panel.
Yes, so thank you very much, Nicola. That was very, very interesting. And I just wanted to ask into the round, maybe to Englim and Iveta, would you like to add your thoughts and your, maybe you have questions or want to add your thoughts on the value of data and on the data sharing and how this might be possible in the future?
Yeah, well, perhaps I'll start, Eva. Thanks, Matthias and Nicola. In fact, I've learned something today from you, Professor Nicola. Value from data, from donating blood to donating data, right? It goes to show the importance of data, right? So it really struck me when I heard that. There are two things I'll just mention. One is de-identification of patient data to anonymization. These are all very important to reassure and meet regulatory requirements, right? Like GDPR, in order to get more data to train with. So a machine is only as smart as the data it is trained with, so we need more. So one of the things here is another layer of privacy we've been working on is a way to connect hospitals who are collecting all that precious data and they're only seeing a few cases each. How do you then network the hospitals so that the machines amongst the hospital can learn from each other without sharing any data? That's a distributed learning method that we are focusing a lot of our energies on to try and provide you with more data and clinicians with more data. So that's one area. It's been published, so I can look that paper up after this session. The other areas I want to mention to you is our recent work with the Bond study. You may have heard of it, where they are recruiting 30,000 people who are 30 years or older and monitor them for 30 years. And hopefully none of them will develop Alzheimer's, but if they do, then they have a 30-year history of early onset. And they bring them in for scans and bring them in for blood tests. And perhaps that's another source of data for you, Claudio.
Thank you, Englim. That is really interesting. I was wondering, because yeah, you were referring to the swarm learning method, and I was just asking myself, because in hospitals, like in maybe some hospitals in rural areas, I was just wondering how would you or what are the challenges for these hospitals maybe to implement swarm learning or all these, considering all these privacy, important things that you need to consider, what do you think, how will this work in implementation then in the hospitals?
Yeah, it's a very insightful question, Eva. In fact, I was asked that same question by the WHO when we approached them about this idea and how to bring that out to hospitals of the world. The theme I used was the hope is to unite hospitals of the world, right? So one of the first questions they asked is, how about those more remote hospitals that are less endowed with equipment? So my answer is yes, that is an issue, right? We should start with hospitals that have the resources to put a machine in their premises and do machine learning for, say, CT scans, and then connect all the hospitals that have the same, they are in the same network, and then those hospitals learn from each other. And then hopefully through some organization, we can provide those services to those hospitals that are more and more remote. And we start with those that have the resources, and then we move outwards from there. It will be a multi-decade, right, or even multi-decade effort. But the goal is to start now, right, and have an organization hopefully backing this, right, providing the understanding so that other hospitals would want to join. The key is, is convincing the hospital administrator that the method used in swarm learning does not share any patient data at all, right? And to reassure them of that. Yeah, that would be, and that your question points to something that needs a decade to solve, but we need to start now.
Yeah.
The goal is not to expect those remote hospitals to buy equipment. No, the idea is they buy services, or someone donate those services to them that they don't have to pay for. And what we really want is the learnings from what their learnings of the data, of their data. We are not going to ask for their data, just their learnings. And why remote hospitals, rural hospitals are important? Perhaps they are the ones that see a COVID-like case earliest, right? Yeah, and therefore the bigger hospitals could learn from them. Example.
Yeah, you're right. I mean, it's always good to start and to think like how this can evolve in future. Thank you very much. I'll hand over to Matthias, who has the next question ready.
I'd like to ask you, Vita, when we talk about data, healthcare, and models, the next thing is ethics. Models can be biased, data needs to be protected. So where do you stand in terms of the use of AI and data and ethics?
It's a very good question, and it connects to the previous answers, because I think it was mentioned that currently very advanced techniques in anonymizing data, also, as Dr. Baum mentioned, sharing data. I would add to this, for example, synthetic data, so mimicking the behavior of certain data sets, starting very small, but extrapolating and actually not needing that a huge amount of PAI data that you need from hospitals. So really the field is advancing to fill the gap and to be able to feed those algorithms. So actually sharing concerns could be avoided from that perspective. But from the ethical point of view, the global communities, including UN, private and public organizations, I think EU and the EU regulations are leading the way in this sense, are trying to unite us around several AI ethical principles. And HP also is defining them for ourselves, for our customers, for the way we do business, for the way we build algorithms. And some of those, there are different flavors in the definitions of the principles, but of course, we talk about trustworthy AI. We are touching on explainability. So all the decisions taken by the algorithms or any kind of guidance we are receiving needs to be traceable and needs to be explainable. Of course, it needs to be security first. It needs to be privacy enabled and human focused, the most important one, I would say, because so everything is about solving global problems or providing solutions to extreme global challenges, and being human focused is a must, especially when it comes to computer vision, to natural language processing, etc. We can also touch a bit on biases. Of course, there are huge discussions on being bias free. But sometimes having the possibility to intentionally embed bias, for example, if we want to be human focused and we want to protect the human on the street instead of the animal as a priority from the in autonomous driving use case, we want to make sure that algorithms are guided in such a way that humans have priority in such a situation. So biases sometimes, and so not always, can be bad. So we have also focused on biases. So those are some of the AI ethical principles that we have been defining together with the global community, with the UN community as well. And I think slowly the different institutions and different governments are coming together. I see it more and more, especially, for example, recently being in a conversation with the German government where they're talking about how those things can be actually technically implemented into a big scale solution. And it's really, really positive to see that. As previously mentioned, the awareness within the community, within the people making the decisions is coming, being there, and simply needs to be embraced.
Yeah, thanks, Iveta. And in a way, there's no society without bias, and thus there will be bias in the data necessarily. Over to Eva.
Thank you, Matthias. We have questions from the audience, and I would like to ask Claudio the first question from Didier Cornell. He asks, how can we share health data to be available for everybody, not only for private companies? Is there a public website for this on the EU level maybe? And is this a goal of the European Health Data Space? And this question is also related to the one of Abdul Razak Karim, who asks, who can we share health data to be available for everybody to government hospitals? Claudia, would you like to?
Well, if someone has a precise answer, I honestly, I don't have an answer for this.
Maybe Nicola, would you like maybe with the Gatekeeper?
Yeah, sure. So as a basis, all the data which are available, so all the data used in European projects are starting with the Horizon Europe open access. So we have in all the project a data management plan, and the data management plan is based on making data accessible to anybody and making data retrievable for a long time after the end of the project. Usually in our project, even 15 years after in specific repositories. So what it's usually happening is that the data, of course, are studied. During the study time, data are not really open access, but then after they get published through a scientific publication, then there will be a link on the scientific publication when you can retrieve the data. So how to make then your data available to one of the European projects? So according to the clinical question that your data may be helpful to, there are usually plenty of in this moment of digital healthcare projects available online, and it is really enough to connect to one of the major PIs of the project and tell that you have data there. You will get in the consortium, so through an extension of usually of the consortium agreement or with a specific agreement, and you will get inside the data management plan. In that case, you can be sure that those data will not be available only to private companies, but are going to be open access after the scientific publication. Yeah, and this is for us important also because in that way the data are going to be cross-validated by other scientists, and this makes also the research in artificial intelligence much more responsible. Because so if you get then the wrong result, other people may find it out. And this is a very important thing to get artificial intelligence at a serious level now. Yeah? So that is usually the way. So just check which data you have, check the clinical question, find out which project is going into that directly into that question. You can really Google into the data federations. There are many of them. And just connect to the PIs and show your availability to participate to that.
My answer will be less specific than Professor Claudio, and it is more at a general level. And there is, of course, Gaia X in Europe, right, which is a data federation, but it's not specific to healthcare, it's general. So that's one area you can look at, GAIA-X. And then there is also other global type data repositories like Wikidata. Go look up Wikidata. It may not be the answer you need, but it is a good place to start to be aware of. And DPpedia, for example. So there are more also general type data repositories. Yeah.
Thank you very much for the answer. I'll hand back to Matthias, who has the next question.
I want to try to get Edmondo and Claudio to speak. And I want to ask you, because as I understand correctly, in the Gatekeeper project, you've been really interacting lots with partners at the hospital level and different areas in the data and healthcare space. Can you share with us some things that really went really well, where you were surprised, or can you also share some really big challenges that you think are, we need to overcome this to make this happen 10 years from now? Please, any of you or any other panelists, in case you don't have anything.
Well, first, I'd like to mention that referring to the development of sustainability development goal of the United Nations, one of the major goals we have to achieve with our platform is sustainability, that is for emerging market, public sector, health in particular. That is why we have set up a brand new system all based on open source software. That is a kind of, let's say, breakthrough that is going to open sustainability for emerging market, as I said, and public sector. It is, of course, it's been taking too much time to set up everything to work perfectly. But in the end, we were achieving this, and we will pursue this system for the market I mentioned before. That is one the main goal. I don't wonder if you want to add something more.
I would say that such an approach, of course, extend a lot the possibility to deploy, to have a larger and larger deployment of this type of solution all around the world. But at the same time, it does not represent a roadblock for the contribution of the private sector, I mean the supplier of equipment, because we demonstrated that on top of the common layer that is totally based on open source, we can integrate, and we leave the pilot to integrate also commercial products. So the contribution of supplier, for example, a large company that develop an MRI system or X-ray system or laboratory systems can contribute, and they could eventually be considered as an extended power for improving the performance, especially in the rural hospital that Dr. Go was indicating as the big issue today, because they cannot invest on premise, but eventually using the large capabilities of the expensive equipment they buy to participate in this large network of distributed computation and training and capabilities. This could be a way to overcome the problem of lack of investment of budget, if you want. So this is not just a closed solution, but it's open also to not open. Sorry for the conflict of the words.
Yes, no, we get it. Thanks, Edmondo. We're now at the hour, and we want to make the transition to the neural network in a minute. We have a couple of open questions, which I think are a little bit specific also, where, for instance, Nicola can maybe respond to one specific question. So we'll all be in the neural network in a minute, and we'll respond in writing there. But before we make the transition, Eva, do you want to ask one last question?
Yes, I have one last question, maybe as a closing commentary to the audience. Englim, where do you see healthcare in 2035? So in 10 years from now.
Oh, you're muted.
Okay, that's a profound question. I would say, hospitals of the world united.
That's a very good answer. Thank you.
Imagine learning from each other, right? Without sharing any patient data.
Yeah, well, I fully support Dr. Go. So, same vision.
Thank you so much, everybody, for joining our panel today.
Yeah.
To the panelists.
And also thank you to you, Eva, for co-moderating today. Thanks to AI for Good for the team behind the scenes who made this all possible, both at AI for Good and at HPE. Thanks to the audience for tuning in. Please stay online. We will be there in a minute. And yeah, thanks everyone. And have a good rest of the day. See you in the neural network. Bye-bye.
Bye-bye.
Bye.
Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.